Hello, this is Ms. DB, and in this video we're going to review how to do some of the problems from the 4.2 worksheet, which is on angle relationships in triangles. Our objective is to apply theorems about interior and exterior angles in triangles. So you should start by reading this section in your textbook to get a good overview. There is some examples on here, but does not explain as well as the textbook does. It's just a little bit of an overview. So the triangle sum theorem, we've talked about this before, but it is that the sum of the angle measures of a triangle is 180 degrees. So this comes in very handy, and you can use it to find the missing angle measures in a triangle. So in this first number 1, 2, and 3, we're going to use this triangle to find the measures of some of the missing angles. So number 1 says find the measure of angle ABC. So you need to remember that when you name an angle, you have the middle letter is the vertex of that angle. So ABC, we would start at A and then go to B and then go to C. It's this angle over here. B is the vertex. We're talking about this angle here. So we have a triangle ABC, and in this triangle ABC, we have two of the angles are known and one is not. So we can use the triangle sum theorem in order to find the missing angle. And you would do that because we know the measure of angle A is 49. We know the measure of angle B. Well, we don't know the measure of angle B, so I'm just going to write B. And the measure of angle C is 84. And we know that that will be equal to 180 degrees. So we can see that to find the measure of angle B, we can just subtract these two numbers from 180. Or we could first start by adding them together and then subtracting. But in any case, you'll end up with what B is equal to by 180 minus 49 or minus 84. Or you could take 180 minus the sum, whatever you get when you add those together. When you do the next problem, triangle or angle DCA, that is looking for, here's D, here's C, we're looking for this angle down here, this green one. So to find it, you'll need to know, let's see, DCA, we don't know this angle or this angle. But remember that a linear pair is supplementary. So these two angles together, the 84 degrees plus angle DCA, are equal to 180 degrees because they make a straight line. So the measure of angle DCA plus 84 degrees is equal to 180 degrees. So we can use that to solve and find the answer for number 2. And then for number 3, CAD, that's this angle up here. So once you know what this angle is here, then we'll be able to use the triangle sum theorem again, subtract from 180 the 46 and the new one that you find, and then you'll be able to find that missing angle. So for the last one, you have to do number 2 correctly in order to get number 3 right. Here we have a word problem that has an asterism, is a group of stars that is easier to recognize than a constellation. One popular asterism is the Summer Triangle, which is composed of the stars Deneb, Altair, and Vega. So we have the angles marked for each one of these. Each one of them has an expression. So we're going to use algebra to find some information. I already started this. I took the 3y plus 13 for Deneb plus the 2y plus 2 for Altair plus the 5y minus 5 for Vega, and I added each of those expressions up, and that's equal to 180. So you need to solve this. You might need some more space, I would. So you can hit return a couple times to get some more space before you print this, or if you're just typing, you can just go ahead and add as many lines as you need. And add your like terms together. 3y plus 2y plus 5y is 10y. And then plus 13, let's see, we've got 13 plus 2, that's 15, minus 5, this is a minus 5, so 15 minus 5 is a plus 10, and that'll be equal to the 180. And then you solve that equation, and you'll find what y is equal to. Once you know what y is, then you're ready to do number 5, which says find the measure of each angle in this triangle. So take whatever you get for y and plug it back into each of these expressions, and you will find the degree of each of those in the summer triangle. Okay, then we have a couple corollaries. A corollary is a theorem whose proof follows directly from another theorem. So these are following from the Triangle Sum Theorem, which again is that the sum of the angles in a triangle equal 180. So the first one is that the acute angles of a right triangle are complementary. That means that if we already used up 90 degrees with our triangle sum theorem, that there's 180 degrees, then D plus E is going to equal 90 degrees, because 90 plus 90 is 180. So that's the first one, that the other two angles in the right triangle will equal 90 when you add them. And the other one is that the sum of, or that the measure of each angle of an equal angular triangle is 60. So each of these is 60 degrees because they're all the same, so 180 divided by 3 is 60. So we're going to use the first corollary, 422, in order to solve these missing angles here. They're each right triangles. So we already used up 90 of the 180, and now you just need to find the other angle. And we know that angle L plus angle N would equal 90, so you just need to find what's missing in each of these. Now in this one, they don't give us a number, they give us x. So your answer will also have an x in it. It's not going to be a number for an answer. So it'll be like 90 minus x, or 90 plus x, or 90x, or x times 180. You figure out, but it'll have an x in it. It won't just be a number. Number 9 is a writing question. In your own words, explain how the corollaries 422 and 423 to the triangle sum theorem make sense and must be true. I've already discussed that. If you need to go back a couple minutes in the video and hear me say why that has to be. But right, in your own words, explain why they have to be true, why it makes sense. Okay, then we're going to talk a little bit some vocabulary here. The interior of a triangle is all of the set of points inside the figure. So all of these would be interior points. And the exterior then, of course, is outside of the triangle. These would all be exterior to the triangle. So we have interior angles. In this one, it's angle 1, 2, and 3. And we have exterior angle, which would be formed if you drew one line, one segment of your triangle longer. That angle formed is called an exterior angle. It's the angle formed by that extended line and the other side of the triangle. There's an exterior angles theorem that says that that measure of that exterior angle will be equal to the sum of the two interior angles that are not touching it. So they say the remote interior angles. So angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Not angle 3. That's not part of this theorem at all. We don't use that one. And then here's how you would use that. Again, we're going to use some algebra. We know that the exterior angle of 126 is going to be equal to the sum of the two remote interior angles. So the two interior angles not touching it. We need to add those two expressions together, which is what they did. That will be equal to 126, and then you will solve the equation. Add your like terms, solve the equation, find what x is, and then go back and say, what are they looking for? They want the measure of angle j. So once I know what x is, I still need to plug that back into the expression for angle j. So let's do, there's a few of these. Let's do number 12. That one looks a little bit trickier. So in number 12, they want us to find the measure of angle m. And we know that angle m expression is 3y plus 1, and we know another one is 2y plus 2. That's the measure of angle n. And we know that the exterior angle is 48. So we're going to use the exterior angle theorem that says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior. So 48 is equal to 3y plus 1, that's one of the interior angles that it's equal to, and the other one is 2y plus 2. So we're going to go ahead and solve this equation. Add your like terms on the left side here, or right side. 5y, and then we have a plus 1 plus 2, that's 3. And then continue solving until we find what y is equal to. So we divide both sides by 5, and we get that 45 divided by 5 is 9. So now we know what y is, but remember that's not done. Now we need to plug 9 back into angle m's expression. So m, measure of angle m, would be equal to 3 times 9, because we just solved for y and got that, plus 1. So 3 times 9 is 27, plus 1 is 28. So this is 28 degrees for the measure of angle m. In 13, I won't do this one, but I'm just going to let you know that this means that it's a right angle, so the exterior angle is 90. So your equation would be that 90 is equal to 7x plus 6x minus 1. And then from there you'd solve for x, and then find the measure of angle L. You should get nice answers for these, you know, like integer answers, or maybe a 0.5 now and then, but they're not going to be like 17.365 for an answer. So you want to check your work if that's what you get. And then the last section is the third angles theorem. This theorem tells us that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must be congruent as well. So we know they're congruent because angle L has one angle mark on it, and so does angle R. So we know those two angles are congruent. And angle M has two angle marks, and so does angle S. So we know they're congruent. So therefore, angle N would be congruent to angle T. And we will use that to solve some problems here with some algebra. Let's look at what we've got in number 14. We have that angle L is marked congruent to angle P. We have that angle K is marked congruent to angle N. So we know then that angle M must be congruent to angle Q because of the third angles theorem. Third angles theorem. So that means that their measures are equal. So the measure of angle, you don't have to write all of this stuff, but the measure of angle M will be equal to the measure of angle Q. So here's what you need to write, that their expressions then are equal. So 6x plus 10 will be equal to 7x minus 2. And then you solve this equation and then find x, and then plug back in to find both measure of angle M and measure of angle Q. Now you should get the same answer for each of them because we just wrote that they're congruent to each other. So let's go ahead and finish this up. It's not going to take very long. We subtract 6x from both sides, so get the variables on the same side. So 10 is equal to 1x, or just x if you want. So we get 12 is equal to x, or 1x. Now that you know what 12 is, you can plug that back into the expression. Now you can plug it into just one and then say they're both going to be the same, so that's the answer for both. Or as a check, to make sure you got the right answer, you could plug it back into both and then double check that you got the same thing for both of them, as you should have. And you'll do the same thing for number 15. In 15, we know that angle USR, this angle, is a right angle, and angle UST is a linear pair with that angle. So we have in previous chapters learned that then this must also be a right angle. If two angles are supplementary and one of them is a right angle, then so is the other one. So these are congruent. It's also marked that angle TUS is congruent to angle SUR. So therefore then angle T must be congruent to angle R. So you can write your equation that 3x equals 2x plus 11 and then finish solving. And then the last one you will do the same thing for this one. All right, let me know if you have any questions. Have a great day and good luck.